VPN and IPsec. I remember telling you guys, I think it was in the last class when I said before we used to have the configuration for VPN in this is in a tree. I don't know why Cisco removed. I'm talking of like lab packet tracer activity. So what I've decided to do for you guys, I mentioned it in the last class, is I will try and get the lab from CCMP and send it to you people. So it's not compulsory, please. It's for anybody that want to practice the VPN. But I will advise you to practice the configuration of VPN because VPN is popular everywhere nowadays. People are always using VPN. People always use VPN. So it is advisable you learn how to set up a VPN network, especially the most popular one out there, which is IPsec VPN. So in today's class, we are going to describe the benefit of VPN technology. We're going to talk about different types of VPN, and we're going to talk about IPsec. IPsec simply means IP security. IP security. So what is VPN technology? VPN technology. What is VPN? So the full meaning of VPN is virtual private network. Virtual private network. So virtual private network, VPN, is used to create end-to-end private network connection. I would have loved to add within a public network. VPN is used to create end-to-end private network connection within a public network. And when I say within a public network, what do I mean by that? You can imagine I am in just right now, I'm connected to the internet. Let's say you are in Lagos or you are in Port Harcourt or you are in Germany, America, doesn't matter where you're in the world. As long as you have internet access and you have a device that we can use to set up VPN, we can hook up. And when I say we can hook up, I don't mean we can talk through WhatsApp call or chat through WhatsApp or whatever. That's not what I'm trying to say. I'm going to explain this in detail as I move on. We can connect my local area network here to your own local area network there. And we are going to create the network, the private network within the public network, which is the internet, as if we are the only one on the internet, or we are the only one that have access to the internet. Whereas other people can also do the same thing, and they will be able to establish end-to-end connection, and there will be no problem. So a VPN is virtual in that it carries information within a private network, but that information is actually transported over a public network. I've just explained that right now. So a VPN is private. That is, they're now talking about, okay, let me put it this way. We said virtual. So they're now talking about what makes it virtual. It's not a physical thing, it's a logical thing. So why do you call it private now? It is private in that the traffic is encrypted to keep the data confidential while it is transported across the public network. So, when we say private, virtual private network, they are telling us why it is virtual. It's not a physical connection hand to hand. Then it's private because your data, it is encrypted. When they say encrypted, it means it is coded from the source to destination. And even if it is intercepted on the way, it cannot be read across the public network. VPN is very popular because of the simplicity and the flexibility of setting it up. So we can see some example here. We can see some example in this place. We can see right now we can see that we have a land here in this area. This is a land here. This is another land here. This is Soho here. You remember I talked about not. Can you see my PowerPoint? Hello? Can you people see my PowerPoint?
Yes, sir.
Okay. So I wanted to
That's
say I
right.
spoke about Soho in the last class. He's not in this class. I started another online class on Monday with some set of people. So I talked about Soho. I think I've mentioned Soho in this class too. Small office, home office. And then we have uh, a mobile worker, which is somebody that can be anywhere in the world. As long as you have internet access, you can hook up with your laptop. And then you have the main office, which is like the headquarter of the organization. So right now, all of these sites, whether the single person or the
Yes,
main headquarter.
sir.
Do you have question? Hello? Okay. Maybe that was just okay. So what I'm trying to say is all of these locations, all these local area network, land, branches, regional office or whatever, what do they need for us to be able to set up a virtual private network? It's just for them to hook up to the internet. And the beauty of this is we don't care how you hook up to the internet. Just get internet access. I- It's possible for somebody to be using a GSM router for internet access. Another person is connected directly to Heltel. Another person is connected to Glow. Another one is connected to MTN. We don't care how you get your internet access. It doesn't matter. We can still set up VPN as long as you have a device that can support that configuration. Of course, our router can support it, our firewall can support it, router can support it, firewall can support it. What about this guy? We can run a software on this guy to be able to also talk to the headquarter and set up VPN in between. So our main tool or the main infrastructure that is needed for us to establish this virtual private network is just the internet. And it doesn't matter where you are in the world. It doesn't matter where you are located. We can hook up. So what are the benefits of VPN? Modern VPNs now support encryption features like IPsec because when you set up VPN, there are different ways to encrypt your packet or your data across the VPN. One of it is IP security. Another one is SSL, and they're all secure. So whether you encrypt your VPN with IPsec or you encrypt it with SSL, it's very secure. So if somebody should intercept that message on the way, they cannot read what is in your message. They can't read the message because everything is encrypted. That's the benefit of VPN in general. Let me put it that way. So what are the benefits? It's very cheap, so you save cost. What do we mean by that? In those days, for you to link two lands together, you need to go and get maybe Airtel. I spoke about that in the last class where we talk about, I say Airtel, sorry, or Nitel or Glow, the people that are carriers, to link your site hand to hand. So you need to get a dedicated one service provider to link your site end to end, and you spend a lot of money. But in these days of internet, all you need is just internet connection. So you just be paying for subscription. Worst case scenario, you can increase your bandwidth. So if you're, let's say, you're on 10 meg before, and you now realize that 10 meg is not enough for you again, you just increase your bandwidth, maybe to 20 meg. So that whatever you are paying your service provider monthly or yearly, as the case may be, that's all you pay. So your service provider does not really know that you are doing you are setting up private network with his own internet connection that he has given to you. He thought he's just giving you access to the internet, but you're also making use of that internet to build a private network. So you are not paying special money to build your private local virtual network, to be your virtual private network. It is also secure. Why is it secure? Because of encryption and authentication. It is scalable. Why it is scalable? You can keep on adding users. More people can join your private network as long as they have internet access. Anytime you hear scalability has to do with growth. You can keep on adding. You can keep on adding. You can keep on adding. It has to do with growth. And of course, that we have compatibility. We are not threatened by the type of service provider you use to connect to the internet. We don't care. We don't care about the speed you use to connect to the internet. All we care about is just have internet access and see how we link you up. So these are the benefit of virtual private network. And so when you want to talk about VPN in general, there are different types of VPN. Let me give room for question from here. Any question on this, please, before we move on? I know Arsenal fans are not here. So the people that are here now, what do we call them now?
Now you are here.
Arsenal fans are here. Oh, now
Yes,
who they
sir.
play? Now who they play today? Now Arsenal or Manchester?
Both of them are playing,
Manchester dey play.
sir.
Ah, you people try though. You really sacrifice. I need to find something for you
Yes,
guys.
sir. Yes.
I will send a lab to appreciate you guys. I will send a lab to you guys.
No problem, sir.
Okay, sir.
Is that one appreciation? I'm giving you work.
I feel
All the same,
appreciation
sir.
All the
because
same.
it's part of the learning process.
Okay. All right. So there are different types of VPN. When you want to set up a VPN, majorly you can classify them into two. We have site-to-site VPN, and then we also have remote access VPN. Site-to-site VPN and remote access VPN. So what is the difference between the two? Anytime you talk about site-to-site VPN, majorly you have a local area network. Maybe this is a LAN, this is a router somewhere, and then you have another router here. This one is hooked up to the internet, and this one is hooked up to the internet. You want to connect this LAN here. Maybe this is a computer here, and there are computers here. PCs are here. So you have PCs here. So if you want to link this LAN, the whole LAN to hook up to the other LAN, meaning you want everybody on this local area network to be able to talk to everybody on this local area network. And the infrastructure you are using to set up this connection is internet. That is site-to-site VPN. You are connecting the whole site to another site. That is a site-to-site VPN. Site to site. So the configuration for VPN will be done on this router here and on this router here. As long as this router are hooked together, as long as the virtual network can be created between these two routers using the internet, doesn't matter where they are in the world, and we'll do every other things we need to do. This LAN can talk to this other LAN here. That is an example of site to site. So sometimes you don't put a router here, it can be a firewall. Router can be on one side, firewall can be on another side. For instance, we have what is called Cisco ASA or Cisco Firepower. It doesn't matter. We can still set up VPN between the two. It could be one firewall on this side, another firewall on the other side, and it's connected to our router, then to the switch, then to the computers on the network. On the other side, it could be the same thing. We can still set up VPN. And some people don't even put router in between. It's the firewall that will be connected to the switch, and then the switch is connected to the users. Firewall on the other side, connected to the switch. This is switch now. And then for with this firewall, we can create our VPN. And people on this network can talk to people on this network. So why would we put a firewall here? For some people, when they hear firewall, they think the only thing firewall can do is just to block virus or to block bad guys. No, firewall can also do the job of router. So some organizations don't even put router on the network at all. They just get a firewall that will do routing, it will do NAT, it will do access list, it will do everything that your router is doing. The firewall machine will do all of those things for you. Okay, so that is a typical example of what do you call it? Site to site VPN. I'm just explaining this my own way now. Now look at what they said here. A site-to-site VPN is terminated on VPN gateways. So when they talk about VPN gateways, we are referring to the routers where we are configuring our VPN or the firepower or the firewall. VPN traffic is only encrypted between the gateways. Internal hosts have no knowledge that the VPN is being used. So the users on your network, if you don't tell them that you are using internet to carry their data to the other location, they may not know. They just know that they can reach Abuja, can reach us using what we don't know. But you, as the engineer, you know how you got the job done. So what about remote access? So for remote access, majorly you have your router connected to the internet, the switch is connected to the router, then you have people on this LAN. So let's assume I'm the boss, I'm the CEO. I don't want to be coming to the office every day. I travel a lot. So it does not matter where I am on the internet or in the world. Great. It does not matter where I am in the world with my laptop. This is my PC. All I need to do is have access to the internet using any means. It can be anybody's network. I will just plug there. An account will be created for me on this router. The moment I put my details, username, password, and then the IP address of my router, zzz, bam, I'll connect to this router, and guess what? I have joined this network. I am on the internet. I am far away from the office physically, but logically, I am in the office. So my computer will join this network. I will get IP address as if I'm here locally. I will be able to access all the computers that are here. We can share resources just like I'm seated in the office. So this is a typical example of remote access VPN. So majorly is for home user or telecommuters, people that travel every time. That is what they uh, we set up for telecommuters or people that work remotely. And that's why sometimes it's not just one person that will be accessing this particular router. Sometimes you could have like 100 people that are working remotely. So now, if 100 people are eating this router, does this router have what it takes to bring in 100 users simultaneously without collapsing under the pressure of 100 users all scattered around the world? So that is why you need to make sure if you are creating VPN on your router and you want to have remote access, you must be sure that the router has what it takes to accommodate all the users that are coming in remotely. And you can see a typical example here. This other the first picture that we have here, you see a router here. Somebody is connected to the router. A switch can be in between, and you have multiple users. So it's this device and this device that will have the VPN configuration. That's why you are seeing VPN gateway here and VPN gateway here. But if you take a look at the next slide, you see that these are VPN gateway. This guy just hook up directly through the internet. As long as it's on the internet, you can join the network locally here. So those are the two major VPNs we have. Others, they can come other side to side or remote access VPN. Now there are different types of VPNs, no doubt, but when you can put this one maybe types and those one class, or this is class or those one types. And we are going to go to those ones also. Now, any question, please? Any question? Are we together, please?
Yes, sir. Yes, sir. We can hear. You're
So
together, sir.
So,
can we continue?
Sir, I just have I have a question, sir.
Yeah, please, if you have question, just raise up your hand so that I can go talk and then give you the floor. Then people can talk one at a time. Raise up your hand and then I can give you the floor. Yes. Who I want to ask question? You can go
Yes,
ahead.
sir. It's amazing, sir.
Yeah.
It's Ghanaian, sir.
Yeah, go ahead, please.
Okay, sir. Thank you, sir. Sir, I just want to ask about the ASA now, the firewall now, like that you made mention of, that it can also do the the work of routing and also securing the network.
Yeah.
So for instance, I don't know. So I just engaged in conversation with somebody sometimes ago. So and the person was telling me about I don't know. He was talking about license. So like that is more important in the ASA on the network. That is the license that. So I don't really get it. I was even doing some research on it to actually know how to check the license and see also learn about the configuration of the user on the network. I just want to know if we are going to do similar thing like that
No, no, it's
on
not
the
in
long run.
CCNA. It's not in CCNA.
Okay, sir.
Yeah, it's not CCNA, but I can just throw some light for you. You need to understand that, okay, number one, when you say you are doing research on it, have they approved the contract?
No, 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 not really. No contract. I was just actually trying to know much about how to actually use the ASA firewall now to shield the network and probably learn more about the configuration on my own. So
Okay.
there's no contract. Yes, sir.
Okay, or you are open for one.
No, not really, sir. Not really, sir. Not
Are
really
you
yet,
sure
sir.
for
Not
one?
yet.
Now, you know why I said that?
Yes, sir.
If you have an organization that wants you to set up firepower for them, which is what Cisco has discontinued ASA now. What they have now is FTD. FTD, that is firepower threat defense. It's the same ASA, but it has become a next generation firewall. So with next generation firewall, uh, okay, let me put it this way: with the old generation firewall, they can all only filter or protect you up to layer 4. They don't have visibility up to layer 7. That is of the OSI model. But with the new generation, next generation firewall right now, they can protect you all the way to layer 7. And with the kind of protection they have is crazy right now. So when you talk about license, if you buy this device now, it can do advanced malware filtering. It can do URL filtering. It can do intrusion prevention system. It can do, there are 4 or 5 major stuff that it can do. But you must buy license. You must pay for each of those services to be unlocked. If not, it's the basic thing, that the basic service of that thing that you're going to get. That's just the basic firewall you're going to get. So when they talk about firewall, it's like giving you a car and saying it's 4-wheel drive, but the basic is you will only drive on 2 wheel. If you want to activate the 4 wheel, pay us. We'll give you the code to activate the 4-wheel drive. Then if that car now has auxiliary J, that maybe you are traveling to a mountainous area and this desert and you need auxiliary J, Cisco will tell you, pay us, we'll send you the code to activate the auxiliary J. You know that kind of it. So for that's why they say better soup for Cisco than money killer. So that you bought the ASA or the firepower doesn't mean that you have access to all the services on that device. You must buy license, you must pay to activate some of the capability of that particular device. That is what license is all about. And while I'm asking about if they have approved the deal, for you to configure firepower for people, a company, that is the next generation, this smallest you can charge is 1.5 million. If you pity them, you get 1 million naira to set it up. Hello?
Yes, sir. I'm with you, 100%, sir. I'm with you, sir.
Did you hear what I said?
Yes, I heard what you said. Wow, wow. I understand, sir. But
So,
honestly, there is nothing related to such. I would have just hint you.
are you
It's
wishing now?
just
Are
my
you
own.
wishing now? Since I have told you how the pay, how it is.
Yes, sir. Yes, sir.
If you want to set it up for any organization, even if they are poor, if you want to pitch in, then you collect like 1 million. But if you don't know your worth and you
Wow.
don't know your value too, you can collect 500,000.
Wow.
You know why? That device they are going to buy, sometimes, what I heard from a friend of mine, FTD, I think 2100 series or 2300 series, I can't remember, it's over 9 million naira.
Yes, sir. I'm 100%.
So
I should
if they
agree with
buy
you.
device of 9 million naira, why won't they be able to pay you tithes of
One
that.
point. Yes, sir. Exactly, sir. Exactly, sir.
So that is why people charge that kind of crazy money to set it up. When
Yes, sir.
organization, if they can afford to buy a device of 9 million naira, there shouldn't be a
Yes, sir.
problem paying you 1 million, 1.5 to set it up. And the funniest thing with that setting up that thing is very easy. Oh. But if you don't know it, you don't know
Honest. Exactly, sir. Exactly, sir.
it. You know, I have CCMP security. So it was one of the exams I wrote. The second exam is on certified specialist in Cisco firewall or whatever. It's my second exam. One of it is on the code generally. The other one is on firewall, firepower. So that is captured in CCMP security, not in CCNA. It
All right,
used to
sir.
be
All
in
right.
the whole CCNA security, but now we don't have CCNA security again. All
Thank you
right.
very much, sir.
You're
It's
welcome.
clear now, sir. Thank you
Any
very much,
other
sir.
question? Any question, please? Can we move on? Am I sure you people are not multitasking,
Mo-
watching
Move
ball
on,
and
sir.
listening to me?
No,
They are
not at all.
listening. I know
We are
what
with
she.
you, sir.
for for for
Remember,
football fans, ba? Okay, so can we move on, please? All right.
That you can always
Yes,
watch the match
you
later.
can move on. Ah, okay, so now there are different types of VPN. I've talked to. I don't know whether I should use the word class or whatever. But majorly what we have is site to site. Okay, somebody is cooking noodles and listening. That's good. It is the energy in the stomach you will take to do the one for the outside. That's Yoruba proverb. Oh. Site to site and remote access VPN. There are all kinds of VPNs out there. There are plenty. If we come to the aspect area of another device like Microtik, another router like Microtik, there are some proprietary VPN that people set up. But I don't want to go into all of that. Okay? So enterprise and service provider VPN. What is the meaning of this? There are some service provider, and when we say service provider, we are not necessarily referring to internet service provider. We're talking about people that can give you wide area network access. They can connect your headquarters to your branch or to headquarters to all your branches. Those are service provider. So these people also use this VPN, but their own type of VPN is different, and that is called MPLS VPN. MPLS VPN. I'm going to just talk briefly on that. The VPN can be managed and deployed as enterprise VPN. Common solution for securing enterprise traffic across the internet. I mentioned that one. It could be site to site and it could be remote access. And they are created and managed by enterprises using IPsec or SSL VPN. They are the most popular. IPsec VPN and SSL VPN. So that can come, those ones can come under enterprise VPN. But what about service providers VPN? Created and managed by the provider's network. The provider uses multi-protocol label switches and layer 2, layer 3 to create a secure channel between an enterprise site. So these people, what they do majorly is to link different sites together using using the technology called MPLS, MPLS VPN. Now, the way this one works is a little bit, it's not about the internet per se. It's about the service providers network. I think I mentioned it in the last class. Where I said MPLS basically brought down the decision of our router to layer 2. Instead of the router making decision at layer 3, using the network in our routing table, it brings it down to layer 2 by using something called label and map the route to label. So if it's going to Lagos, instead of say checking the routing to a table to see the network address of the destination where it's going to, It will just check the number that is mapped to that network address. That is how MPLS operates. But MPLS is a different training on its own, so we cannot talk about MPLS in detail. I did MPLS for the first time when I went to India for my CCIA. I didn't know about MPLS before, but it's going old. It's becoming a legacy also. So, still talking about VPN. So now we need to dive in and see the types of VPN we have all around. We've talked about remote access VPN, which I've explained, and it can come in different form. One, it can be clientless. The other can be client based. What is the difference between the two? This one, you use your browser. You use your browser to connect. This one will install a particular software on your computer for you to connect. All these ones they come under remote access. And I have explained remote access to you earlier. You can see an example here. This is a computer. For you to get to the headquarter, all it needs is just the browser. Put the IP address of this particular firewall at the headquarter. And by the time the destination, the packet is accessible to the destination, the firewall gives the interface to put the username and password of whoever wants to come in. And if you have the correct username and the correct password, you enter. Whereas the other one here needs a software that must be installed before you can use it. Now, let me read what they said here to you guys. I think it's important. Remote access VPN lets remote and mobile user securely connect to the enterprise. Please mute yourself. So it helps the mobile user or remote users to securely connect to the enterprise. And I've taken my time to explain about the remote access VPN. And I've also talked about site to site VPN. Okay? But basically, apart from talking about the site to site or the remote access, when we want to implement or want to set up this our VPN, we can either go for IPsec VPN. We are talking of the implementation now, or the SSL VPN. We have IPsec, we have SSL when we want to set it up. So it therefore means I can decide to do site to site and I'm running IPsec. I can decide to do site to site and I'm doing SSL VPN. Or I can do remote and I'm running IPsec. I can do remote. I am doing SSL. It doesn't really matter. It depends on what I want to achieve because you are going to see the difference, the advantages and the disadvantages of what do you call it? These VPNs. They have their features, they have the things they support and stuff. So if you know that IPsec cannot take care of what you want to do, you go for SSL. If SSL cannot take care of what you want to do, you go for IPsec. It just depends on what you are trying to achieve. So let's talk about SSL briefly. SSL uses the public key infrastructure and digital certificate to authenticate peers. This is another word of its own. Digital certificate is a word of its own in cyber security or in CCNA security. Public key infrastructure is a word. We need to talk on those ones in detail if we are doing security. But this one we'll just mention them in passing. The type of VPN method implemented is based on the access requirement of the users and the organization's IT processes.
Clothes on the floor.
Mr. Debo, can you please mute yourself? Mr. Debo. The table, we have a table here now. It compares IPsec and SSL remote access deployment. So it depends on what you want to do. So look at what they are saying here. If I'm doing IPsec, what are the things I stand to gain? What are the features I get? If I'm running SSL, what are the things I am going to enjoy? The first one is application supported. IPsec is extensive, almost all IP-based application. This SSL is limited, only web-based application and file sharing. So, if I have an application that is not web-based, even though it's very difficult nowadays to have application that is not web-based, then I cannot use SSL. Then when it comes to authentication, this one, the key is strong. This is moderate. Encryption strength. This one is strong. This can be configured from moderate to strong. Connection complexity, medium. This one, you don't have any stress. You just require a web browser on the host. You are good to go. Connection option. This is limited, but for this side, it is extensive. Any device with a web browser can connect. So VPN is a word of its own. There used to be a track in those days on VPN. As in, if you want to do certification on VPN, there used to be a certification on VPN. It's a track of its own in those days for you to know that this is not child's place. But if dismantle that particular track and then they spread this VPN, some into maybe CCNA, some CCNP, some CCIE, and stuffs like that. So these are just the basic features you have under SSL. Of course, we talk about site to site briefly. We can connect two sites together and our traffic is encrypted and so on and so forth. The clients don't even know that you have VPN because it's about LAN to LAN. Now, this is another one. That is why I did not want to say your VPN packet or data is encrypted because I can decide to configure this thing called GRA tunnel, generic routing encapsulation. It's a form of VPN that can link my two sites together. But guess what? It's a non-secure site-to-site VPN tunneling protocol. You will have the end-to-end connection through the internet, but your data will not be encrypted. That is why, if you want to use this particular protocol to set up VPN, they tell you to run it over Ipsec. So why would I need to run GRA over Ipsec when I can just configure Ipsec and enjoy end-to-end data encryption and security hand-to-hand? Oh, sometimes VPN does not allow you to do what you want to do. Like what? I've taught you guys about OSPF. OSPF. Let's assume you want to run routing protocol between your sites. You can run OSPF on top of IPsec, but you can run OSPF on top of GRA tunnel. So sometimes you need to mix up the two. You configure GRA, is not secure by default, on top of IPsec, which is secure by default. Then you can now run your OSPF on top of GRA tunnel. And that is beyond the scope of this class. So that is why they will tell you that GRA tunnel can support multicast and broadcast traffic. IPsec does not support multicast, and our routing protocols use multicast to communicate between themselves. So GRA tunnel does not support encryption, so it doesn't provide security for us. So the only way for us to secure our packet is to encapsulate that GRA packet inside of IP packet so that we can forward it securely to the destination. Now, setting up this in Cisco or Cisco router is crazy. DRL over IPsec is crazy. But I've seen the configuration on another device that I've seen like, my goodness, is that hard? That's the end of everything. I couldn't believe my eyes. But if you understand the concept, you won't have a problem setting it up. So just be aware that that is available. Okay. So still talking about GRL over IPsec. The terms used to describe the encapsulation of GRL over IPsec are passengers protocol, carrier protocol, and transport protocol. These are some of the things involved when you are running that particular protocol, generic routing encapsulation. So what is passengers protocol? This is the original packet that is to be encapsulated by GRA. It could be IPv4 or IPv6, a routing update, and more. What about carrier protocol? GRA is the carrier protocol that encapsulates the original passenger's packet. What about the transport protocol? This is a protocol that will actually be used to forward the packet, and this could be IPv4 or IPv6. It's like one is coming, the journey is starting from IP, and our IP packet is now wrapped up inside of GRA tunnel, which is our carrier protocol, and everything is wrapped up inside of our TCP, which is our transport protocol, before you can go to destination. And if we now put it on top of IPsec, another encapsulation is going to take place again before you can go to destination. So this is what I was trying to explain earlier. For example, branch and headquarter need to exchange OSPF routing information over an IPsec VPN. GRA over IPsec is used to support the routing protocol traffic over the IPsec VPN. Specifically, the OSPF packet, that is, the passengers protocol, will be encapsulated by GRA carrier protocol and subsequently encapsulated in an IPsec VPN. So if you know you are going to be running routing protocol between your locations, you know that IPsec cannot support what you want to do. You have to bring in GRA over IPsec. Now somebody will say, where do I use this? Even if you don't know where to use it now, somehow, somewhere in the future, if a demand is placed on you, at least you have had it, you'll be able to do more research on how to get this thing done. And this configuration is very simple and straightforward. Okay. Any question on that one before I move on? Any question? If we are doing CCMP class right now, I will have been demonstrating GRA tunnel for you guys. GRA over IPsec, side to side VPN. We will have been doing the configuration. So, but this is CCNA. All of these things are not taken care of in the CCNA. They just mention them and then we move on. Okay, I believe we don't have questions. So another type of VPN that Cisco came out with, I think is a Cisco proprietary. It is Cisco proprietary. It's called DMVPN, Dynamic Multi-Protocol VPN. And this is used for when you have multiple sites. Like when this one just simplifies the configuration of VPN. So take for instance all these banks that have, let's say, the headquarter, this is the HQ, and then you now have BHO, another BHO, another BO. You know what is called BO? BO is branch office everywhere. And now you want to use VPN. So let's assume this guy is connected to the internet and we want to use VPN to bring all our locations together. It's going to be cumbersome for you to be configuring this is one after the other, one after the other, one after the other. Let's imagine you have, say, 300 branches. So in order to solve this problem, to 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 make this thing very easy and to reduce the complexity, Cisco came out with another VPN called Dynamic Multi-Point VPN. So with DVM VPN, we can connect all these branches to this headquarter with DMVPN without stress. And what they did, they took the GRA tunnel, put IPsec on top of it, manipulated some things in the configuration so that we can achieve this without stress. And the configuration also is very simple and straightforward. So if you don't want to have complexity in creating VPN between multiple sites, you can go for dynamic multi-protocol VPN, which is a Cisco proprietary protocol. It uses what is called hub and spoke approach. This is our hub. This is at the spoke, just like your bicycle. The headquarters is the hub and the branches are the spoke. And even the spoke can talk to themselves through the hub, except if you want to explicitly block them. But without that, they can talk to themselves. Wait, oh, this thing is moving without me touching it. Okay. Now, this is another type of VPN that is there available. It is called VTI, IPsec VTI. I think it's a new one. Not that new, but I heard about it some times ago. IPsec Virtual Tunnel Interface simplifies the configuration process required to support multiple sites and remote access. Now, let me give you an example. Let me say something here. Let's assume I have a contract to do. I want to link, like, let's say 20 locations, 30 locations, and stuff, and they are using Cisco routers or they are not using Cisco routers, and I don't know which of the VPNs to use. All I'm going to just do is I will research GM VPN. I will research IPsec VTI. Since I've heard about it, simplifies the configuration process. Personally, I've never configured this IPsec VTI, but I've configured DM VPN. Not in the field. I'm talking of personally practice. Okay. After the research, you'll be able to come to a conclusion on which one to use. So what do they have to say about IPsec virtual tunnel interface? They said it simplifies the configuration process required to support multiple sites and remote access. Remote access. Now, IPsec VTI configuration are applied to virtual interface instead of static mapping the IPsec session to a physical internet. Now, because you have never configured any before, some of this may not make sense to you. Okay, let me just leave that part and go down. IPsec VTI can be configured between sites and in a hub and spoke topology. And most of the time, you want to set up your this in hub and spoke topology. Why? Because you are connecting the headquarter to the branches. Sometimes it's just for you to hear about a particular technology. As long as you have the foundation, strong foundation in CCNA, and then you are given the configuration guidelines, you are good to go. You see the design, you see the configuration guidelines, you are good to go. And for Cisco to put it in this CCNA, I know this is very important. I have never researched this. I've never looked this up. But I'm just thinking, I think I need to check it out personally. Because Cisco don't just do things for no reason. Whatever they are doing, if they put something in the curriculum, it is because it is needed for the current environment. And I have talked about MPLS VPN. This is used majorly by the service provider. This is not about you trying to link your sites together yourself. No, you contact them. They give you point of presence in all your locations, wherever you are. But within their own network, they use a technology called MPLS VPN to make the delivery or the transmission of packet from branch to another to the headquarter to branch faster. And I wouldn't want to go into MPLS VPN because that is a word of its own, but it's used mainly by service providers. So you are not the one to configure it. They will configure this within their network to link different customers together. All right. Any question?
Not at all, sir.
Okay, so let's go to the last
No question, sir.
okay, the last part of the class. Okay. So now we are going to now dissect IPsec itself and see some things inside of IPsec, even though we are not going to do the configuration. So let's check out some of the things we have inside of this IPsec. So IPsec technology. IPsec is an IETF standard that defines how a VPN can be secure across IP network. I've explained some of those stuffs. IPsec protects and authenticates IP packet between source and destination and provides these essential security functions. So what are the things we stand to gain when we configure IPsec between our locations. Number one, confidentiality. What is confidentiality all about? It uses encryption algorithm to prevent cyber criminals from reading the packet content. So confidentiality, we are safe. Why? Because our message is encrypted. Then another thing we start to get there is integrity. It uses hashing algorithm to ensure that packets have not been altered between source and destination. So there's hashing algorithm in use. So what is the job of this one? If I'm sending you $1 million, it's going to conduct kind of a test or a computation. That's the right word on that money, on that message rather. After the computation, it's like you grinded that message into powder, and then you weigh it, and then you got some information about it, and then tag it that this thing though, by the time you get to the destination, this is what should be gotten though. That is what hashing is all about, and that is to maintain the integrity of the data. So our hyperset uses hashing algorithm to make sure that our packet is not altered between the source and destination. Not that I'm sending $1 million to Mark and somebody has cut off the packet and changed the destination and is going to another person. So because of this hashing algorithm, it's not going to work. Another thing we start to gain is origin authentication. Origin authentication. What does that mean? It will authenticate the source and authenticate the destination. So if I want to talk to you, the two routers must have been configured to authenticate themselves so that the enemy does not come in between. So that enemy does not come in between. So we have to be sure. Okay. Somebody is asking a question. What is the difference between SSH and IPsec? SSH is used to log in into your router. SSH is used to log in into your router for you to configure the router, work on the router, and it is a secure connection, remote connection into the router. But when we talk about IPsec, we are talking of you are connecting one location to another location using the router. So this is not about you as an administrator. I'm in class now. Hello, Mr. Toye, ẹ jẹ́ kí n pè é padà, mo wà class. Mo wà class, ẹ jẹ́ n pè é padà. Hello. So IPsec is you connecting two locations together using those routers. Not that you are entering the router for the purpose of configuration or checking things in your router and stuff like that. So that's the difference between the two. I don't know if it's clear. Mr. Arigbabu, is it clear? SSH, remote login into the router to configure the router.
Yes, sir.
IPsec, you are linking two locations together using the router. It's about LAN to LAN connection.
Thank you, sir.
All right, sir. So now, another thing, okay. Another thing we start to gain with our IPsec is Diffie-Hellman. What is that? That's another form of algorithm. Actually, it's used to secure key exchange. It's an algorithm to secure key exchange. What type of key? For me to talk to you and for you to talk to me, we need to make sure we have the same key. Meaning what? Are we configured to exchange information? And those keys must be exchanged securely also. Because if a criminal can get one of your keys, then the key is as good as gone. So these things we are now going to break them down again now. These are called the building blocks of IPsec or IPsec framework. Now, listen now. IPsec is not bound to any specific rules for secure communication. Meaning what? Tomorrow now they can improve on it. They can add more to it. There's always a room for growth in IPsec. Now, IPsec can easily integrate with this security technology without updating the existing IP standard. There's room for that. But this is where we are going. The open slots in IPsec framework shows in the figure can be filled with any of the choices that are available for that IPsec function to create a unique security association. So what is the meaning of this? What is the meaning of this? Let's find out. This is the framework for IPsec. This is the framework for IPsec protocol. We say we have confidentiality, we have integrity, we have authentication, and we have different elements. So the moment I run IPsec on my network, I start to enjoy, or I am supposed to enjoy all of these things, but not every time. What do you mean by that? Because there are different types of IPsec protocols that I can activate. This is one of it. AH. If I activate AH, I don't get confidentiality. I get integrity. I get integrity. So this my pen used to move this to another slide. I don't know why. Okay. I get authentication. I get secure exchange of keys remotely. There's another protocol that I can activate under IPsec. If I activate this, I get confidentiality. I get integrity. I get RSA, that is authentication. That is a type of authentication. Anyway, I didn't mention that. And I can also have access to secure exchange of keys. But there's also another one. We can decide to merge ESP with AH. Meaning I'm not just doing this, I'm also doing in combination with this. What do I get there? I get my confidentiality. I don't get integrity. I hope I'm correct. I don't get authentication, but I can get secure exchange of my keys. Let's go to the slide to see what we got there. Okay, look at what they are saying here. Look at what they are saying here. Choosing the IPsec protocol encapsulation is the first building block of the framework. Meaning what? You have to decide whether you are going for AH or ESP. I don't think that combined one is popular. IPsec encapsulates packets using authentication header or encapsulation security protocol. The choice of AH or ESP establishes which other building blocks are available, which I just highlighted for you guys. AH is appropriate only when confidentiality is not required or permitted. So when you don't want to have confidentiality for your data, that's when you use AH. But what about the other one? ESP, Encapsulation Security Protocol, provides both confidentiality and authentication. Let's move on. So what is confidentiality? What is confidentiality? What is confidentiality? Confidentiality is basically just to make sure that our data is secure. If it is captured on the road to destination, it cannot be read. But there are different encryption algorithms to get this job done. Look at, we have DES, we have 3DES, we have AES, we have SEAL. Even this AES, it has 128-bit key, 192-bit key, and 256-bit. Now, if you have done CCNA security or cyber security, you are going to see some of the things about this key length where we talk about cryptography. But this is not a class for that. We just have to highlight some things briefly and move on. Now, look at what they are saying here. This is least secure. This is from the most secure down to the least. This is from the least to the most. So if I really want my VPN to be very secure, I go for seal encryption algorithm. If I don't want that, I go for AES. And even under AES, the longer my key, the more secure my confidentiality, all the algorithm. So 256 is more secure than 192, and 192 is more secure than 126, 128 bits. And I'm going to explain that in a layman way. This is just the idea. If I encrypt something, let's say 256 times, multiply by something. So before you can unlock it, you need to be able to generate that numbers of keys. So 256 is higher than 182. It simply means you have more work to do trying to decrypt something that is encrypted with 256-bit keys than encrypting something on 182 keys. So the higher your key length, the more secure the algorithm. But guess what? The more your router is going to work. It is like in my place, they said, a child has said, Mama no go sleep, too no go sleep. If you don't have a robust router, if you go and put zeal on the router can freeze because the router does not have what it takes to run this particular algorithm. If it does, if it supports it. So sometimes in some of the devices, you may not even see that it supports the seal or the advanced AES. You will have to go for 3DS. Or you will have to go for DES. But you need to know the lower, if you go for DES, you are not that secure. Even though it's encrypted, but after maybe too much effort, they can crack your data. So you make sure you go for the most secure if you have the device that can handle that. I think I need to read something to you here. Look at the way Seal operates. Seal is a stream cipher, which means it encrypts data continuously. Rather than encrypting blocks of data, Seal uses 160-bit key. What does that mean? It keeps on changing the keys. It keeps on changing the key. So it's very difficult for the bad guys to capture that key and decrypt it because the keys that is using now is not what it will use next. Another key that is using next is not what it will use, and so on and so forth. So you need to be aware of that. So this is one way. These are different encryption algorithms that we can use to secure our VPN. So when you are setting it up, the higher you go, the better for you. Then what about integrity? You know what integrity means? I've explained that. I want to be sure that if I send you $1 million, you get it when it gets to you. It has not been tampered with, it has not been reduced, or the destination has not been changed. That is what integrity is all about. So under integrity, we have the algorithm for integrity, MD5 and Sure. Sure is more secure than MD5. It's all about the keys and the technology. So if you have your way to configure Sure, those will enhance the data integrity of your network when you are doing VPN, you definitely should go for Sure, not MD5. That is that about integrity. And what about authentication? You remember we said the two devices that are communicating must authenticate themselves. They must be sure that they are talking to themselves. The correct guys are talking to themselves. So we have a way to enhance or to set up this authentication. The first one is PSK, which is pre-shared key. Pre-shared key is you give a key on this router like password, a key on the other router. But it doesn't really scale. That's why you can move to what is called RSA. RSA is reverse, Shamia, and Halduma. They don't use key. They use what is called digital certificate to authenticate themselves. So the routers can use digital certificate to authenticate themselves. And this is also beyond the scope of CCNA. These are things we teach in cyber security, or in those days in CCNA security. And the last one is for these devices to be able to exchange keys securely between themselves. The key also will be encrypted if they need to exchange keys. And there are different algorithms also we can put in place. And you can see this is most secure And we have another one here. This is from DH14, 15, 16, 19, 20, 21, 24. We have DH2, we have DH1. And this is all about allow the peers to exchange shared key over a secure channel. So if you don't configure, if we don't have this, when they are exchanging the keys during the process of association, what they call security and association, it's like the VPN tunnel is trying to set up, is trying to form. Somebody can capture that key and we'll be able to know that, okay, this is the key that these routers are using to communicate with themselves, or the keys that these firewalls are using to communicate. So we are not just encrypting the data that we are transmitting, the key that they are also using to set up communication between themselves will also be encrypted. And so these are the building blocks of your VPN. IPsec VPN, sorry, not just VPN in general. There are others, but they are not covered in CCNA. These are just the ones that are covered in CCNA. IPsec VPN in particular, then IPsec VTI. Any question? So that we can release the arsenal fans.